Now, finally, the HTTP response message. Okay, the second type of messages in defining the HTTP protocol. You see here, generally, 3 parts. First, the status line. Second, the header lines. And the third, the data. So the entity body, so to speak, from here and down. Okay, and these are very similar to the header lines we see in request message. Each line, you see attribute and the value. Attribute and the value. Status line. 1, 2, 3. Again, 3 components. Let's go through each one of them as well in a bit more detail. In status line, first here, familiar. So the version of HTTP the server is implementing is the first component in the status line. Second, this is the status code. Okay. So in HTTP, it defines quite a number of these status codes. Each of these indicate a different condition. Some more related to the server, some more related to the object being requested. And for each of these status code, there's a status word being shown as well. That's the third component in the status line. So 200 here indicates okay, meaning the HTTP server is working well and the object you're looking for has been found, and it's going to come here in the body entity. Now, second part, the header lines, we see date. Yep, this is the date, time, the request is being filled, and this response is being generated. The server, this is an Apache server, version 2.0.52. Yep, Apache is one of the most commonly used web server implementation. Yeah, I think you heard about the other one, Nginx. So Nginx is certainly rising. Okay, it's not quite yet the most popular one. Well, let me clarify. By popularity, I meant the number of machines running a specific version of web servers. So Apache is still the most used web server. But if you count only the number of downloads recently, it might be Nginx. That's why you see I said that it's actually rising. Okay. So I think maybe in just a couple months, there will be more Nginx server than Apache servers. Last modify. So this is to indicate when is the object you're downloading last modified. Oh, okay, it's really long time ago. All right, e-tag. What is this? This is actually, for each version of the object that you are downloading, there comes also with a version number. So e-tag there is to indicate the version number. Nowadays, as you see, the HTTP protocol is not used only for downloading purpose. It can also be used for uploading. If there are multiple users there using different web browsers trying to upload the file, for example, Polly and P, and Caleb, the TA, tries to upload and override the grades Excel file, then you might have a consistency problem there. So the number here is to break tie, to make sure that a newer version does not override an older version or something like that, to resolve conflicts, so to speak. And accept range. Yep. So, you know what? Earlier when I mentioned the head comment in the HTTP request message, right? So when you send such a comment in the HTTP request message, the server responds with only the status line with the header lines, but without the data. Okay, so server there can actually tell the client, you know what, I'm a server that allows you to request content in terms of bytes. So the client there seeing this can then send the request more officially instead of using the head command, using the real get command and request to download byte 0 to maybe 1023 or byte 0 to byte 100. Okay, so you could do a range request in a way. And the server's next header line, content length. This is to indicate the size of the file or the size of the object that you're downloading. So you see the file size of the object is one critical parameter. Okay? If you're implementing a web server, you need to know a way to find out what the file size is or the object size is. Okay, the size is a bit messy. Let me clear the markups. Keep alive. Oh, good. This web server implements persistent connection. Okay, and so it indicates timeout interval is 10 and maximum 10 requests. So this is a persistent connection, but in the connection, it only accepts up to 100 requests. All right, so if it's more than 100, then you will force close. The server will force close the connection. So connection, keep alive. Content type, yeah, just like the client size header line we see. Yeah, the client accepts content of a certain format. Here, okay, this is to indicate the object the client is asking for, which format it is. And we see this is text-based HTML file and it's coded in ISO AA59. Right? And empty line, indicating this is the end of the header lines. Right after the empty line, the data goes here. If it's an HTML file, then hey, text starting from here. Okay, the first file. So this is an example of HTTP response message. You see the structure is very much like the HTTP request messages. Next is just to share a bit more. HTTP response message is status code. We've seen earlier in the example 200 OK. This is saying request is successful, object is already embedded. 301, that means the server is saying the object is moved to a new location specified later in this message. So sometimes when you run into a message like this, you see, oh, click here. That's going to take you somewhere else. It's a redirecting link. If you see status code 400, that means your HTTP request format is not quite correct. Bad request. 404, that means the object you're asking for is not found. 505, HTTP version not supported. So in case you're using a very, very, very old browser, or if you're contacting a server that's very, very old, and yet your browser is implementing something newer, then you might not be able to communicate. The server is going to tell you this. Sorry, 505. Good. And now we're ready to look at an example of what HTTP request and response might look like in real life and in action. So what I will show you in the demo coming next is to do this. Telnet to the favorite web server here, and we're going to use this machine here that the textbook author has set up for us. So we'll telnet to gaia.cs.umass.edu at port 80. Okay, what it does is to open the TCP connection to port 80 where there's a server already running, a web server already running. And anything typed in will be sent to port 80 at this guy. Okay. So Telnet is a remote logging application, just like SSH. or RSH if you know what it is. It's another remote logging command for native Unix users. Alright, so Telnet is very, very old. Many operating systems probably doesn't support it anymore. But I've already installed it on my Mac, so we're going to show that in a little bit. Now, once we telnet to the web server, and we'll type up some things. Okay, let's try typing this. Get path name and file name as the argument for the get command, and then the version of the web browser. So we'll be pretending that the telnet here is a HTTP 1.1 client, and host gaia.cs.umass.edu. Right, so header line. So essentially, we are trying to do a human web browser. Okay, by typing online right here an HTTP request message. So once we are done with this, we hit return. Okay, and then we hit return again. Needs to have a what? A \r\n here in order to complete the HTTP request. All right, so the whole thing is going to be like this. And yeah, we'll see what pops up in return, what the server there at umass.edu sends back. Okay. Let's not sniff the traffic. Let's just look at the response coming out of the telnet program. All right, so let's switch to the demo mode.